Good morning, good morning.
Are we ready to start this morning?
Ready to start.
We can go ahead and go?
Yeah,
Is it okay to go, Jared?
you can go.
Okay, I'm gonna go ahead and go, Jared.
You can go.
Well, good morning. How's everybody doing? This morning we hadn't had one of these. We've been skipping a little bit because of our exciting field trip that we've got coming up, and I'm going to talk about that some. But right now today we had some Ask Powermetrix Anything questions. We did get some good questions in here, a couple of real good curveballs. We're going to talk about them, and then we're going to talk about the field trip. We're heading out this Sunday and going to a customer, and we're going to be testing. You can see on there 3S, 4S, 5S, 6S, 8S, and 9S meters, and have already determined some of them are going to be some very interesting voltages and services. So it should be a great week. We're going to get a lot of material that we will use for a lot of webinars going forward. So here's our first question that we had come in. So Michael's asking, it says, testing the secondary line voltage on the line side of a meter socket that is being fed from a 240 volt direct buried delta service that is ungrounded can give spurious voltage readings due to inductance. Would you comment on methods or instrumentation to identify this? Well, first of all, being in Tennessee, I called up Michael to find out what spurious meant. It's kind of a big word for around here. Spurious.
That's
yeah.
25-cent word.
Yeah, it's 25-cent word. Yeah, it's funky or goofy or something like that. Voltage readings is what we're used to hearing, or messed up or jacked up or something like that. But spurious. So we did call Michael and get a little bit more information on this. So Steve and I talked with him. So Steve had a little bit of a conversation with him. So I'm going to lateral it off to you and let you answer this one.
So basically what Michael described to us is that we had an underground service and we actually had multiple conduits, going into the same thing. And he said some of the times the problem that they would have is they might have one part of that conduit that's not got a load on it. And so the issue is that the meter man would go out to the meter, and actually take out his multimeter, which is a high impedance, and he would hook it up and he'd be getting a reading. And the reading wasn't quite at line voltage, but it wasn't low voltage either. He might got 60, 70, 80 volts, where you would normally expect to get, say, 120. And so we believe what's going on here is basically, you've got these cables, these big conduits laying in a trench going side by side. And so you've got some influence of one cable on another, basically. What way I call it was capacitance, capacitive coupling from one cable to another. Normally you've got a low impedance load on the end of that, meaning you've got a load up there, you've got lights, you've got a motor, you've got an AC unit, you've got whatever. But in this case it was disconnected. And so what you've done is you've gone and you've taken that high impedance multimeter. Typical digital multimeter is going to be typically around 10 mega ohms, 10 million ohms. So what that means is that it doesn't take a lot of capacitance for a little bit of leakage current to get into that multimeter and get a reading off of it. I think what we discussed was probably the best way to do that in a perfect world would be if you could put some sort of load on it, i.e. a load that's much lower impedance than that multimeter. Because what that's going to do is that's going to, if there's not voltage hooked up to that line, that's basically going to pull it down so that you see no voltage, right? As long as you've got a little bit of load, or at least a smaller load than the impedance of that multimeter, which is very high, that would help you make sure that you're getting a correct reading. Because otherwise, like I said, it doesn't take a little bit of current, a little bit of leakage current from one line to another to be able to get that meter to think it's seeing really a voltage that's not there.
Okay.
Anything? I think you covered it pretty well. All right. This was done purposefully to try and throw us a curveball by our good friend, Mr. Billy Williams. And he did. It says, can you verify that a single phase load connected line to line, A phase to B phase, in a 120-208 volt service can be tested with a 3 series? Is it possible to see the mathematics for this connection? In other words, the example that was given to us by Billy was you have a 240 volt water heater and you connect it up to A and B phases. And it should be, it's a 120-208 system, but he just connected he went line to line with it, so nothing going to the neutral. So then what do you do with, how do you make your connections and how do you work it out with this? We don't have an answer as far as the mathematics, but we can talk about what we need to do to get there, right?
I would still say we could still test that with a 3 series. I'm sure that would, I mean, hopefully there's gonna be some current on C phase. He did mention that it was a 16S meter. So, I guess the thing of it is that 240 volt appliance. In other words, it's a single phase appliance.
Yeah.
So,
As long as the service type was set up from line to line, I think that would work, because, I mean, the way the 3 series works is you got voltage, you got current. As long as you're measuring the voltage phase to phase and the associated currents with that, you've got the right service file, then you
Oh,
should be
yeah,
able,
yeah.
you should be able to get the right answer.
yeah, I agree
The,
with that.
the trick that we discussed was, normally with a 16S meter, you've got, say it's a 4-wire Y, it's a 3-phase service, you've got a voltage, you got 3 voltage stators, you got 3 current stators. You expect the voltages and currents to be, the power's being computed, the voltage with its respective current. In this case, you're going phase to phase, so you're taking 2 voltage stators, I assume, and doing that, or you're going voltage to neutral. I didn't ask Billy that question. But once again, as long as you've got the voltage and the associated current that goes with that, the meter should be measuring it correctly.
Yeah.
If the PowerMaster's set up to measure that, it should work.
Just as long as there's phase relationship.
Yeah. Yeah, but that was a good curveball. Thank you,
Yeah.
Billy.
Yeah.
We owe you for that one.
I'm gonna
That's
set
right.
food with that this weekend.
These are the ones we always love to start out this way. Hey, guys, I have a weird one. Yeah, if I had $1 for every meter out there that they took me to test and said, we've never been able to test this one before, John, let's go to that one. I well, sure, let's go. Okay, hey, guys, I have a weird one. I came across an old service, a 9S meter with the CTs located inside the building, built into a cabinet. What I noticed when investigating to get to the CTs to check the ratio was there are actually 2 sets of CTs, 6 total, all wired to 1 meter. All the CTs are going to the correct phases. They're all the same size and brand. The meter just has 2 places to get current from for each phase. Paralleled CTs seems to work and test okay. The CTs are 600 to 5, so the multiplier would be 120. So we did ascertain that the meter will accept multiple currents, is what we found out. So he is actually running, he's got 6 CTs. He's running all of those CTs are all going into the meter at the same time. So it's not like a redundant backup or something like that. It is reading all of them at the same time.
So is this from let's say that an office building upgraded, they put a main further back in the business and ran a set of CTs to the transformer? Is this what's going on here?
That's what it made it sound like, yeah. You had
Yeah.
two installations, and
Yeah.
basically you've got a set of CTs for each part of that, but it's feeding one common.
Different part of the building.
Is what it was, so. The trick here is if you think of a CT as a current source, if you go back to circuit theory, you can say I've got one current source, another current source, I put them in parallel. The 2 currents are going to sum together. That's going to work fine for the meter test because the meter's seeing basically 1 current because the 2 sum together. The trick's going to be if you try to do a ratio test on the individual CTs,
Yeah.
you've got to be able to get to the respective primary and secondary currents for each CT to get the ratio correctly, for it to work right. Either that or you can go and basically say, 2 of these in parallel, I'm going to have to do a little bit of trickery in terms of how I'm testing it because you've got 2 currents summing together for the secondary, so that, once again, is the trick. You have to be able to, I guess if you added the primary currents on both CTs and you added the secondary currents, once again, it would give you the right ratio. You'd basically be testing 2 CTs at once. Either that or you could break it out and do it individually. the way
So
I
you
look
have
at
to
it.
make sure the flex rings are wrapped around each.
Both, yeah. They'd have to
Okay.
capture both primaries, which if the CTs are removed from each other, that'd be sort of hard to do.
Yeah.
The trick there is you could actually go and hook up your flex around, say, the primary on one CT way over here, and then you got the secondary wire coming out. You'd have to be able to basically measure that current
Yeah.
coming out of that secondary. If you tried to measure it back at the meter's got both currents coming in the
That's
secondary.
right, you
Therefore,
jack it out.
it's gonna give you a bad reading.
You gotta go individual, so you gotta go to this CT, because it's always with the CTs, right, it's just, we don't have to worry about the voltage, just current, it's primary and secondary current.
Yep.
So if I get the primary current on this CD, I just gotta get the secondary current at that
Associated with
individual,
it- with that one
CT,
CT.
with the one CT.
Either you get all of it, or
That's
you
right.
get them individual.
That's right.
Yeah.
If you try to do it piecemeal, then you're gonna get a weird answer.
That's right. Gotcha.
Steve is on the chat and he says, Ray, they do have 2 load centers, so yes,
Okay.
that looks like what happened.
Okay,
Nice.
that makes sense. I've ran into one like that before, but I got out there and I was looking at the site, and what was the big problem was the meters were, what they thought they were billing to the back of the business was not right. It was actually measuring the group that was up front. And so they had those meters mismatched from the beginning the whole time. They both had the same 605 CTs. And the only way that we found it is we shut everything off in the front of the building to see what meter was what.
Which one was right?
Right.
So how much were they getting a good discount off of
They
that,
were
Ray?
getting a
or-
very good, big huge discount.
I bet.
Huge discount.
They didn't want to see next month's bill, right?
No.
Dave Woodcock, if you can enter in on the chat room and tell us if you mean quadrants for channels, that's what we talked about this for just a second, and where it says here, it says any future plans to measure 4-channel data for end-to-end testing. This would help when power factor fluctuates between lead and lag while testing 4-channel meters. Are we talking about 4-quadrant meters?
Yeah, I think that's what he's talking about.
I would
Yeah,
think so.
that would make more sense, because of course with 4 quadrants, basically the issue there is you've got, it's measuring watts, it's measuring bars, it can measure leading and lagging. So a true 4-quadrant meter can switch between leading and lagging for both watts and bars. And so, I mean, yeah, the good news is Powermaster actually will do that. It will
Yeah.
actually measure it in 4 quadrants just like a 4-quadrant meter will. So yeah, it can do that.
Yeah, you need to set it up.
We've simulated that. We've actually simulated capacitive as well as inductive loads to make sure that we can measure in all 4 quadrants. You know.
Nice. Did Dave answer whether that was 4-quadrant?
Not
Chad?
yet.
Okay. But there's a little bit of a lag there, so I would guess that's what he's talking about there.
I'm assuming you're gonna see a lot of issues with that is gonna be at your renewable sites.
Yeah.
You know, where you're gonna have
Solar.
bi-directional, current flow, and also worried about whether it being leading or lagging.
Because Martin just sent me something, as a matter of fact, last night. He was saying if you had any issues testing solar sites.
Oh, yeah, we've been to several.
Steve's been a
solars.
sub.
Yeah, we've got one out in East Waxhaw, actually.
Dave says yes, it is 4-quadrant.
Cool.
Okay, yeah.
Cool.
Yeah.
Thanks, Dave.
And you just mentioned solar. I've got one question that came in late.
Oh, I don't know if we answer late questions.
Give me 1 second to find.
Yeah, Martin was asking about that.
Was it?
Yeah, well, when I went up there and tested all those up in Massachusetts that time, we did a day of nothing but solar farms. It was, you had to stop and
You
think
can
a
see
little
some
bit.
interesting stuff.
You gotta stop and think a little
Oh,
bit
yeah.
sometimes.
All right, James Trombetta says, what do you think about the electric utilities industry's pressure towards renewable and alternative energy? When photovoltaic panels and batteries lose efficiency and must be replaced, will all the toxic waste create other hazards worth accepting? We can put wind turbines in the ocean so we don't have to see them, but is it justifiable to accept the risks? Do the pros outweigh the cons?
That's a good one.
Um,
That's a tough.
That's a good one. I mean, depending on your political persuasion, we
Yeah.
could go either way on that. I'll tell you this, though, from my experience with solar sites, because I've been to several solar sites, not so many of the wind farms. The real trick with renewable sites is really payback, and a lot of that goes to efficiency. Photovoltaic cells the industry's credit have gotten a lot better in terms of efficiency over the last 50 years, but still best case, I think they're still only about 20 or 30% efficient. And of course, that depends on how much sun you've got. If you're someplace out in the desert, out west, where you've got a lot of sunshine, your payback's gonna be pretty good on that. If you're in good old East Tennessee, it might be just as cloudy as it is sunny on any given day. We get a lot of rain here, and so you're probably looking at a pretty long term of payback. In terms of environment, I mean, that's the other thing you have to consider, is that, of course, you're burning fossil fuels versus that. I mean, you're always gonna have to have power, regardless, The only way to combat that is to get more efficient loads, i.e., electric vehicles, utilities that use less power, things like that. So ultimately, in my mind, it goes back to having a more efficient load. You need to have renewable energy, but you also have to have loads that are more efficient so that you consume less energy.
Yeah.
Because until, like photovoltaics get up to the efficiency point that you can match, a steam plant, coal-fired steam plant, you're still gonna have to use just as much energy. There's no way around that. So it's
about
a
how you-
two-pronged approach there. You gotta make what generates the energy more efficient, you gotta make whatever consumes the energy more efficient.
Such as That power factors you're talking about,
Yeah.
harmonics,
The
really
thing,
need to pour.
the thing right there is, you know, you go out and you buy a new refrigerator. I bought a new refrigerator a few years back, and, you know, it's got, on big letters, Energy Star compliant.
Yeah,
Direct drive motor. Direct drive motor is a DC motor. So what are they doing? You're plugging that into
Switch
a
it to a
120 volt
power
AC outlet.
switch
They've
to
got
DC
a
source.
DC source. You got an AC to DC converter. That AC to DC converter is going to generate harmonics.
Yeah,
It's going to generate nonlinear loads. It's going to generate a lot of VARs that are going to go back on that system. And so,
The
just
head
like
on the
we-
root beer.
Yeah, on the root beer, that's right. Head on the root beer, you know. I mean, the other thing there, it's like we've talked a lot about green lighting, you know, compact fluorescent light bulbs, LED light bulbs. Back in the early days, those were pretty nasty in terms of the fact that you were doing either a frequency conversion or an AC to DC conversion, meaning that even though I saved a lot of money in terms of watts on those green bulbs,
oh yeah.
there were a lot of harmonics being generated, being put back on the system, and that can wreak havoc for the utility, so.
So back to the refrigerator, so the refrigerator that you purchase is good on your part, but it's
Yeah.
actually
It's
vice
hard
versa to the utility.
to the
company.
utility company, yeah, because they're gonna see a lot more harmonic
Yeah.
load off that. It uses a lot less watts, which is good for me, because I'm being charged for watts, but in terms of harmonics and VARs, utilities still gotta make up for that.
Mm-hmm.
So,
Interesting, right?
and all the loads are that way nowadays. Pretty much every system
Everything.
that you use eventually runs off of DC. And
Yeah.
so the point being is there's an AC to DC conversion, at which point there's gonna be harmonics and VARs being generated. And utility just has to be able to make up for that.
Mm.
But it's a good question.
That was a good question. So we've got, talk a little bit about the upcoming schedule. As I was saying, we're gonna leave Sunday and go to a utility, and we're going to do the filming on testing these sites, 3S, 4S, 5S, 6S, 8S, and 9S. We already know some that have some interesting applications that we're gonna run into, some interesting service types. So we're really looking forward to it. It's gonna be a full week. So we think we're going to get a lot of webinar information out of that. If there's anything you can think of on any of those meters types and meter forms that you would like to see something when we're out there, please send that in to Jarrett. Any suggestions you would like to see, any tests you would like to see. We're going to be doing load boost tests. We have some that we know don't have any load on them, so we're going to be doing load boost tests out there in the field. We're going to be using both a 7 series and a 3 series to test with. So you're going to get to see just about everything by the time we're done with the week there. So a lot of different sites, a lot of different tests, some interesting situations we already know about we're going to run into to show the capabilities of how to use the equipment to find stuff, how to find these issues. So we're really looking forward to it. So that'll mean the week. So JP, we're going down there all that week. That next Tuesday, are we going to have one?
Oh, yeah.
Okay, so we're going to have a webinar the week of, so it'll be the 20th.
Yes, sir.
Okay.
I might have to work over the weekend to get it produced, but no big deal.
Okay, all right. So if JP says we're having it, we're having it. So evidently we are having one. April 20th will be the first of that series of the live testing webinars we're going to do. So be sure and get in on that. I think it's going to be some great training, actually right there live in the field. So anything else, fellas?
That's got it.
Okay, that's got it. Well, I didn't start with one, so I'm going to close with a prayer. But I just appreciate everybody coming on here. Appreciate the questions. And we're really excited about next week and getting all that filming done and getting some real good information from some webinars coming forward. Not only to view them immediately if you happen to be lucky enough to have the time to watch them, but also for people's libraries for testing during safety meetings and all kinds of stuff. So it's going to be, of course, they'll all be put in there by JP into either YouTube or on our website. So you'll have access to that. So if we're done, I'm going to pray us out, and we're going to be in the field next week, but then the following week we'll be in here with some great new material to show you guys, all right? Thanks again, everybody. Precious Heavenly Father, thank you so much for this time today. Thank you for these men that have come alongside me this morning. Thank you for the information, for the great questions we had this morning, and Father, keep us safe out there next week. We're going to be out there doing live testing, and the information that we're going to gather up is going to be great for training for folks and maybe helping somebody not get hurt out there in the field. And that's the main thing with all this, Lord, is us just doing everything we can to see that people get home safe to their families. And I lift this country up to you right now. Father, we know we're going through a lot of stuff right now in this country, but in the midst of all of it, the thing that gives me comfort, and I hope it gives other people comfort, is knowing who is actually in control, and that's you, Lord. You're in control at all times about everything. There's nothing that you are not in control of. So all of these things I ask and say according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Cool. Thank y'all. Appreciate it.